Alrighties, hello everyone and welcome to your pre-lesson video today on trigonometry. So we have quite a bit, so let's try to make this as brisk as possible. Alright, so the very important thing that you do need to remember are these trigonometric ratios, at least for sine, cos, and tangent. Alright, these are the three most important. Alright, so with sine, essentially you're looking at opposite over hypotenuse. So let me quickly draw a triangle out for you. Let's label this A, B, C. Okay. So whenever we're referring to the sides, we are looking like across it. So for A, the opposite of it would be 9. And for C, the opposite of it would be 6. Now, we wouldn't look at B just because we know directly across of it would be the hypotenuse, right? So normally whenever questions asked, it wouldn't be asking for the opposite of the hypotenuse just because it's impossible to find, all right? So let's take into reference for A for all of these. So sine A will be the opposite, which would be 9 over the hypotenuse, which is square root 117. You would also use Pythagoras theorem, which essentially is a squared plus b squared equals c squared to find the sides of the legs, but we will get into that further down in geometry. All right, now with cos, it is adjacent over hypotenuse. Now, essentially, adjacent would be the side that is right beside it. So for, like I say, let's look at A. So opposite, right across it, is 9. Right beside it would be 6. We wouldn't count square root of 117 because we know that that is the hypotenuse. All right. Remember, the hypotenuse is always the side that is right across the 90-degree angle, which is given by this sign. All right. So opposite of A, 9, adjacent of A, 6. So for the cos, will be adjacent over hypotenuse. Tangent would be opposite over hypotenuse. Now, cosecant. Cosecant essentially is just sine flipped, as you can see. So if you know sine, you should know cosecant because it is flipped. So it's hypotenuse over opposite. Now secant is cos flipped, all right? So it'll be 1 over cos theta, so hypotenuse over adjacent. And cotangent is obviously tangent flipped, so it'll be 1 over tangent theta. Okay? So now let's look at some practice things. If, like I say, we already actually found what sine 8 is, right? Because it's 9 over square root 117. Now let's look at cos C. So cos C. So what is adjacent of C? 9. So 9 is on top, and we straight away also know the hypotenuse is 117, right? And we actually see the relationship between sine A and cos C. We will get into that in a second when we get into complementary angle relationships. All right, so now let's look at sine C. So opposite of C, as you can see, is 6. So it'll be 6 over square root 17. Now what's tangent A? So we're looking at angle A. So opposite 9 over 6. With trigonometry ratios, you don't need to simplify it unless obviously the answer option doesn't give you the full one, then simplify it. But normally, if you leave it as 9 over 6, it's fine. Okay. Now let's look. Cosecant A. I know that cosecant is just sine flipped, so in this case, I know it's hypotenuse over opposite for A, right? So if you take here, we're just going to flip this upside down. So it'll be square root 117 over 9. Now secant C, I know secant is just cos flipped, right? So that means these two flipped. Square root 117 over 9. Secant A, I know secant A is going to be sine flipped, right? And sine always opposite of hypotenuse, so if you flip that, it is hypotenuse over, secant is cos flip, so it'll be adjacent over hypotenuse but flip. So hypotenuse over adjacent, which is 6, and then cotangent A is tangent flipped, so adjacent over opposite. And there we go. If you have any questions about trigonometric ratios, bring it to your deep dive lesson. All right, some basic trigonometric identities to remember. At least remember tangent theta equals sine theta over cos theta. So if you've given sine theta and cos theta of an angle, right? So it'd be like sine A cos A. It will equal the tangent A, and here is y, right? Don't need to remember this. As long as you just remember just this, that's fine. But here's y, tangent theta equals to sine theta over cos theta, right? So we know that sine and cos essentially is going to be opposite over hypotenuse, all right? And cos is adjacent over hypotenuse. Now, as you can see, these two have fractions at the bottom. So we want to get rid of the fractions, and to do that, we're going to multiply by the hypotenuse to get rid of it, right? So it gets rid of these. So that leaves us with opposite over adjacent, which is essentially tangent theta. And that's why tangent theta equals to sine theta over cos theta. All right? If you have any questions about that, bring it to your deep dive lesson. Complementary angle relationship. So essentially, complementary angles are just two angles that, when summed up, equals to 90 degrees. So essentially, it's x plus y equals 90. All right. So, and then if you notice in the diagram before, right, sine of an acute angle is equal to the cosine of its complement. For example, sine 20 equals to cos 70, because 20 plus 70 is 90, right? So these two would be the same value. And same thing is cos 20 equals to sine 70, because obviously 20 plus 70 equals to 90, right? So that means these two would be the same thing. Because of this, we can actually figure out that sine x would equal to cos 90 minus x, right? So whatever x here is, we can find out what cos is. And vice versa, cos x equals to sine 90 minus x, all right? So let's look at actually a little bit about how the sine of an acute angle will equal to the cosine of its complement, right? So let's see, we have P, Q, R, 3, 4, and 5. Okay, so let's look. Let's take sine P equals cos R, right? Because we know 90 is the hypotenuse. That means P and R, when added together, should equal to 90, meaning these two, P and R, are the complements, right? So let's look. Sine P, opposite of P is 4, and our hypotenuse is 5, so we can write it as 4 over 5, right? And then we look at cos R, so adjacent over hypotenuse, so also 4 over 5. So can you see how sine of an acute angle is equal to the cosine of its complement? It's because of this, right? That's why it's true. Now with the formula that we're given, right? Say for example, given sine 37 degrees, what is the cos of its complement, right? That's the only information that we're given. Now, keyword is sine 37 and complement, which means 37 plus something equals 90, right? So we know based on the formula that sine 37 would equal to cos 90 minus 37, which would equal to cos 53. And that's how you would use complementary angles, the complementary angle relationship, to solve the problem. All right. Next thing that we have are radians. So most geometry questions present their angle measures in degrees. Now there's also a different unit that sometimes will be asked, which is radians, and normally this is given in terms of pi. You would just leave it in pi, right? What we know is that 180 degrees is equal to pi radians. All right, and then these two are your formulas that you should remember so that you can convert. As long as you remember one of them, you should be able to use the other because you're just essentially substituting it. Okay? So let's convert the following degrees into radians. All right, so in this case, I want to use this formula, right? So that means it's 35 degrees times pi over 180. When you put it into your calculator, just ignore the pi because you want to leave your answer in terms of pi, right? So essentially you're going to do 35 divided by 180, which would finally give you 7 pi over 36. And that will be the angle in radians. All right, now let's try the other one. 225 times pi over 180, right? Again, don't put pi in the calculator, just do 225 divided by 180, which would give you 5 pi over 4. That's it. All right. If you have any questions about converting degrees to radians, bring it to your deep dive lesson. Now to the flip side, we're now going to convert radians into degrees. All right. And now from that, we're going to use the formula that is given, right? So in this case, we're going to use this one. But if you're not sure how, you can also just use this and substitute as needed, right? So to find the angle in degrees, we're going to do 2 pi times 180 divided by pi. Essentially, you're just going to multiply the number. So 2 times 180 would give us 360 pi. That's all. All right, because why we can just do 2 times 180 because I know my pi's are going to cancel out each other. So just straight away look at the numbers, multiply them. All right. Now with this one, we have pi over 3 times 180 over pi, right? So pi over 3 is our angle in radians, so we want to find it in degrees. Cross multiply. Now 180 divided by 3 is going to be 60 degrees. All right. And then this one, 10 pi over 7 times 180 degrees over pi, right? These cancel out. Now I'll get, let's see, 10 times 180 will give us 1800 divided by 7, which would finally give us 257.14 degrees. All right, and that's how you convert your angles from radians to degrees and vice versa. Okay. Now, the next thing that we have are benchmark angles. It's not necessary to memorize all of this, but it is really, really helpful to know what the benchmark angles are. So I'm not going to go through this. You can look at it. If you want to memorize it, by all means. All right. Now, on to the next thing. We have the unit circle. So with the unit circle, we essentially questions ask you like, which quadrant is this in? For where would it be positive? And here's why. So let's see, we have, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? So their hypotenuse is always going to be a positive, as you can see, because this is going up this way, this is positive, and because this is going to the right, it's also positive, right? So that means everything here, where the sine, cos, tangent, and their flips are all going to be positive. So we're going to put A for all. All right. Now for this. Again, hypotenuse is positive. We're looking at this angle. Because this is going up, it's going to be positive. But because this is moving to the left, it's going to be negative, right? And from there, I know, because if we're looking at what would make it positive. So opposite over hypotenuse would be sine. So sine would be positive, and cosecant, because it's this flip, will also be positive. And everything else will be negative. All right, so that's why we put S. Now for this one, again, we already know that X is, this is going left, so it's negative. Then now this is going down, so it's negative. And then again, hypotenuse positive. Now what would make it positive, right? So we can't include anything that has a hypotenuse because everything else, like opposite over hypotenuse, adjacent over hypotenuse, will make it negative. So that means opposite over adjacent will make it positive, right? So that's why tangent is positive and so is cotangent. All right, and that's why I'll put a T. Now for this, we know, again, as usual, hypotenuse is positive. This is going right, so it's positive, but this is going down, so it's negative. All right, so we want something that is positive, right? So we look, adjacent over hypotenuse will make it positive, and we know adjacent over hypotenuse is cos. So that's why cos is going to be positive, and so would be secant. All right, and everything else would be negative. That's why I put C. So essentially, you just need to roughly know that in quadrant 1, everything is positive. In quadrant 2, sine and cosecant are positive. Quadrant 3, tangent and cotangent are positive. And cos and quadrant 4, cos and secant will be positive, and everything else is negative. All right. So with your unit circles, as we go into the deep dive lesson, we will see how this would come into effect. All right. But for right now, for your pre-lesson video, just remember all of this, and as usual, if you have any questions, especially about the unit circle, because I know it can be a little bit confusing, shoot me a message or bring it to your deep dive lesson. All right. Alrighties, that is the end of today's video, today's lesson on trigonometry, guys. If you have any questions, like I said, send me a message or bring it to your deep dive lesson. Alright, thanks for tuning in. Have a good rest of your day.